I apologize for the last lecture. I didn't have the recording on for the full lecture, so I ended up just posting what I had, and I posted last semester's version of lecture one. So if you want to go back and view that, you'll be able to. All right, perfect. So I see people could see my screen, and we'll get started here. So today we'll be mostly going through homework one, as well as picking up on a couple of the points in the discussion board that we've been going through over the past 2 weeks. So that would be weeks 2 and 3. And then we'll sort of preview homework 2 and sort of go through anything that might have been challenging from homework 1 and how to sort of approach the second homework. So with that, I'll just get started with a few examples in R, showing how I ended up approaching a few examples of how to approach homework 1. So for homework 1, it was a pretty pretty clean data set, a few cases that weren't complete, and it was really an exercise in data exploration. So basically in being able to look at a data set and just sort of find sort of let the data inform what kinds of visualizations that you're making. So with a lot of the questions, a large part of the question was what sort of visualization best answers these questions, what kind of data set is it, and how do you best explore it. So with that, we'll just get into my R script here. So I'm just using sort of your sort of standard packages that you would use for this, mostly ggplot, and just using dplyr and plyr for some of the data manipulation. So once we bring it in, we could get an idea of what this data set is. So you could just kind of quickly take a look at it. We have each line, each record. You sort of see what's happening here. So in this case, each record is just a company, and we're looking at various. We have some questions to answer about that. We do hear I'm hearing some, yeah, sorry about that. Looks like the mute has gone. Cool. So we have just sort of previewing our data set. We could just preview it there, or just sort of look at a head or a summary of the data. So this kind of gives us a good idea of what we're looking at, and sort of gives us some preview into some of the state-specific questions that were part of the homework. So one of the first things that I asked you guys to do was to just exclude any row that has NAs. And the best ways to do that is just to use complete cases. So here we're just simply filtering our data by that. So here I'm just using dplyr to do that. So we have our new data set, and then I'm going to aggregate the data by state for the first question. So the first question, it's pretty clear in looking at a summary for each state. We're just looking at how many companies are there, and so really it's just that one was the most straightforward and seemed to be one that I don't think anyone really had issues with. But if you're looking at that, you just simply use the built-in use dplyr to aggregate that. I don't know if anyone else has been runs into issues if you're using dplyr and plyr and sort of having the functions repeated. So you sometimes have to just specify that you're using dplyr. So firstly, just to kind of get an idea of what we're doing, this is just looking at all of the states. So kind of first brush at what we're looking at, and then when we're getting into what the question in particular was asking, which is it's a specific format, and just sort of looking at other things that might help to really make the order clear. So first of all, when you are looking at a large number of cases like this, so in this case, large even being 50, but if you're looking at bars and you're looking to make comparisons, it really helps to have them ordered in sort of the size order, so you could sort of have an idea of where each state is located. So this it's pretty clear what the number one state is, but even trying to find out what and I'll zoom in so that we could see this. But even trying to pick out what the number 3 state is might be a bit difficult. I mean, possible, but it requires more work to do something like that. Whereas if you just simply reordered that, so here this is just doing some more sort of making it a more of a final sort of project. So here, what I'm adding to it is adding coordinate flip and just adding a theme here. So I'm using this package GG themes, has a pretty useful Tufte theme, which pretty reliably gets rid of a lot of the extraneous markings and gives you a pretty concise visualization. So here, for something like this, it's better suited for a more portrait orientation, and ordering it lets you very easily see what the number 3 state is, which is what we're looking at for the other 2 questions. So here you're able to really easily see that that's New York that's popping up there. So as I mentioned, that was one of the that was pretty straightforward. I don't think anyone really had that many issues with that first question, but it does sort of show the sort of the steps that you're taking in the exploratory data process. So you're sort of starting out by using ggplot for yourself, just trying to see what does this data look like, what do we have available, and sort of then working with the visualization to produce something that is more of a final version, something that would be meant for sort of how you would communicate what's happening. So you'll see that more in the other questions as we answer them. But any questions so far? Cool. So for the next question, we'll just simply filter the data by state, and we'll sort of get a first brush at what we're looking at. So the second question is sort of imagining that you're working for the state, and you want to sort of compare employment across different companies. And unlike the first question, this is looking at this is sort of more looking at the distribution of companies. So when we we have a number of different companies per state. Each one of those companies has a number of people employed, and we're sort of interested in finding out like more about per industry what does the company distribution look like. So so basically, one of the best ways to kind of approach a question like this is to start out with kind of the simplest visualization that you could think of to view something like this. So in this case, each case is a company. Each row is a company. We're looking at what industry it's in versus the number of employees, and we're able to look at something like that just as a scatter plot. So for this first sort of brush at trying to find out what's happening, we are going to just simply do that. So we have our industry versus employees, and we are just simply adding a geom point to make that a scatter plot. So something like this, and again, this is sort of more for sort of your own personal use, like just looking at the data, trying to understand what's happening and what you need to do in order to come up with your final visualization. So in this case, and this was mentioned in the question, to watch out for outliers, it's pretty clear where we see those outliers. So here you could have, you see that most of the companies are within this range here, and we have two pretty major outliers. And obviously, like there are a lot of different methods of dealing with outliers. Basically, I didn't, I wasn't too concerned about the sort of method that you chose. Some people used quartiles. Some people would use standard deviation. Really, any of those are valid, and really, just what I was looking for was that you were able to sort of pick something that some sort of metric and remove those outliers, and then sort of create an easier to read visualization where you're able to see what's happening here. So what we're doing here is just simply picking a sort of top and bottom value to sort of clip our data, and more importantly, we're keeping that sort of keeping what we're removing and just simply kind of sliding it over so that we could view it in an easier to read chart. So for something like this, I just sort of used 2500 as our clip here, and that allows us to pretty much get rid of the major outliers and kind of see what's going on here. So, but you could see that within this, you could just simply replace that value with anything. So then let's view that. So now we obviously have more of an idea of what's happening, and so here you could kind of see like you see more of what's happening. That we have clustering of smaller companies. And then we have kind of a more general kind of for mid-range companies, and something like this, we're able to see that, and we're also able to still have those outliers in the graph. So these three right here are going to be what we're going to have to deal with. So using a scatter plot is a good way of just kind of getting an idea of what's happening with the data. But for something like this, it's it's not kind of ideal to show this sort of distribution. And there are a few different ways of showing that. I and a lot of people ended up choosing a box plot to do that. So looking at something like this, we're just simply adding that geom box plot instead of geom point to that same graph, and we get more of an idea. So this just sort of aggregates the data, so allows us to sort of focus on the distribution rather than focusing on the individual points. And of course, we still have outliers within the box plot, but those are just sort of outside of the interquartile range. And this is 99% complete, but the last thing we just need to do is make sure that we deal with those outlier companies and properly explain what's happening. And the easiest way to do that is just simply to annotate. So here, this is adding a few annotations and sort of showing what's happening here. So we have just our points here that are labeled by what the actual values are. And I'm sure you guys have seen sort of versions of this where you have kind of ways of dealing with outliers, perhaps broken bars, or in this case, just simply labeling the points. And while box plots work in terms of giving you that distribution, there are a few different ways that you're able to do something like this. So the box plot, that's just kind of using the default way of constructing box plots, usually the median with the first and third quantiles, so showing the interquartile range. And there are, if we do want to sort of get more technical, we could kind of choose what we want, how we want to display these ranges. The line at the end of the box is, so basically so George asked, and I apologize if I'm mispronouncing your name. George asked if there's any meaning to the lines, and in this case, this is a box and whisker plot, as it's sometimes known. So you have the box, and then those are the whiskers. And the box is the interquartile range. The whiskers go out, I believe, 2 standard deviations, and then anything beyond might be one standard deviation. I'll check the exact definition of what ggplot uses there, but usually it's sort of based on standard deviations and then showing outliers outside of that. So usually you won't have, and a lot of times you won't even see points like this. So it's pretty much just illustrating the interquartile range and then the rest of the range. So in this case, it's just showing outliers. .5 IQR, that's the whiskers, Aaron? Yep, cool. So that's sort of using a built-in way of aggregating these points, but you are able to come up with your own. And a lot of people had their own unique ways of looking at this. So here we could sort of aggregate the data ourselves, look at the ranges and averages of the data sort of in its own data frame here, and then we could begin building visualizations that are based off of those. So in this case, we could choose to use the average instead of the mean if we want to do that, which can sometimes be problematic, but in this case, we'll just sort of see what that looks like. So here we're looking at, and this is actually the median. So we're looking at the median here. And we're using this geom point range. So that's another built-in geom for ggplot. Just looking at the lower and upper. So it has the sort of benefit of letting you define what your range is going to be and how you want to plot that out. So we're just going to plot the point range and then see what that looks like here. So this is similar to a box plot, just kind of gives us another sort of another way of looking at it. So sort of use it like this, and then you could also add these error bars over a bar chart. So looking at this, it's actually adding, looking at just a standard bar chart, but we could add these error bars here. So this is very similar to this approach, except instead of pretty much instead of points, we're looking at these bars to signify what the median is. So here you could see what that looks like with the bars. And I think a few people, like one or two, I think, chose point ranges to look at this distribution, but a few people also chose bars. Any of those are valid ways of looking at this, of answering this question. So any questions on that second question? Cool. So we'll just move on to the third, and so for the third question, it's pretty much just looking at another measure of these companies, and this is pretty much just another view of the data. So the second question, we're looking at we're the state, we're concerned about employment, so we're analyzing the companies in that way. And as an investor, you're more focused on the revenue, and in this case, the revenue per employee. So what we're able to do, just first of all, we need to calculate that, which is fairly straightforward, and then these are just a few ways of doing something like that, and then sort of plotting out something like this. So we could use box plots to look at something like this as well, but this time I wanted to show another way of looking at these sorts of distributions. So here, this is kind of looking at it in a more exploratory way. Again, there are outliers that we might want to deal with in a situation like that. But using something like this, which I'm about to show, you actually get a clear idea of the full distribution. So everything that we've been showing before, like all of these types of charts, it's kind of based off of individual values. So showing interquartile range, showing sort of standard deviations if you choose to use that, and kind of sort of estimating a distribution using around 3 data points or more if you're looking at outliers, but sort of mainly looking at a small number of data points to summarize the distribution. But what ggplot also allows you to do is to create a kernel density plot. So here we're just going to look at our plot, and instead of looking at this, instead of looking at a box plot or looking at the error bars or something like that, we're going to be using this geom density. So this automatically calculates the kernel density and sort of shows more of a view of what's happening with the distribution. And in addition, because of the way that we're looking at this, we're going to sort of be using the principle of small multiples and using facet wrap here. So in this case, we're facet wrapping by industry. Facet wrap works pretty similarly to everything else that you're looking at in terms of ggplot. You just simply append it to the plot, and you choose which variable you are you're faceting by. Facet wrap, you choose one, and then with grids, you could get more sophisticated with that, as some people mentioned as we were talking about small multiples in the discussion. So now something like this gives us a lot more information about what's going on. So rather than just showing one point, this gives us an actual idea of what the distribution looks like. So as we're getting into here, we could begin to notice patterns that wouldn't be apparent if we're just looking at box plots or sort of more summary based visualizations. So you could see whether there's sort of like a lot of them do look fairly normal, but do we have any underlying patterns? So for something like real estate, for example, do we have, or not real estate, insurance, for example, we have an interesting bimodal pattern going on. As someone looking at these sorts of stats, one might be interested in what's causing something like that. Is there kind of a bifurcation of the companies? Sort of looking at how fat or skinny these distributions are, how long the tails are. You're able to get sort of that information from a chart like this. So those were a few of the choices that I made, and then just looking at want to highlight one person's approach to something like this, which is sort of an interesting take on the on looking at small multiples and distributions. So rather than showing it in a faceted sort of way, and this is Judd. So he chose to look at this as a sort of one on top of the other, and something like this, it kind of sort of gives a nice view, first of all, of how the averages are skewed. In this case, by the outliers. But this is also an interesting approach that I've been seeing in visualizations recently, where you're sort of able to almost get a 3D effect to your distribution simply by repeating the lines like this. Yep, and someone asked if I could share the scripts. I will post that. So does anyone have any questions for homework one? Questions or comments? So basically, the sort of main takeaway for this and for future homeworks is a big portion of it is trying to trying to sort of find out what the question is asking and what the best visualization for the data is. So in terms of questions like in terms of questions like that, it helps to kind of to sort of look at simpler visualizations, sort of play with the data a bit and see what you could find out, and then sort of let that guide what you end up with. So when you are looking at data where you have individual cases, and in this case, like you're sort of looking at the distributions, sort of thinking about how you're going to show that, something like, so sort of the most common mistake in a lot of these sorts of questions was, just showing the average, just showing the median, and those, sort of those don't show enough about what's going on under the sort of with that data set. Just saw a link of it's I thought there was a package of that, and I actually tried to find this before the lecture and I couldn't, but I have been seeing it all over the place. Yeah. Oh, and there's also ridges. Yeah.
The second link shows an example of a GG joint.
Let me check that out. Thanks. Yes, this is exactly what I was looking at. So it gives an interesting sort of 3D effect of well, in this case it's not really 3D effect, like, but what I have seen is when this is overlaid over a map, it gives a really cool it gets a really cool effect. Like all you really need to do is, have like if you have population by for individual latitudes, you could end up with a sort of 3D looking sort of population map. So it's interesting to see this trend appearing. Cool. Thanks for that link, Walt. Yep, this is exactly the one that I was, the sort of stuff I was referring to. So it's, it's interesting because it's so tightly packed, but, it sort of lets you, see that, like it's still pretty much just one line for each observation, for each row, but, kind of ends up giving you another effect there, which I thought was interesting. Cool. Any other comments on homework 1 before we move on to the second module? Cool. So for this second homework, we're going to be looking at, let me just get the raw here. I didn't open up the link. We're going to be looking at New York City Pluto data. So I have an interesting question from someone here. So basically, yeah, so this is basically sort of comparing different ways of looking at charts. Or some people predisposed to older style graphs. Are there sort of different sort of if you are in professional setting, are there certain types of graphs that sort of get the point across? Are there do you want to sort of keep things simpler? I would say that sort of in the context of looking at something sort of trendy like this, if you are in a professional setting, it might be a bit confusing. So it sort of depends on who your audience is and what you know about your audience. So let me just quickly, don't know why it wasn't letting me access the link before, but here we go. So here we're using, for module 2, we'll be using a very large data set. So in this case, it's the Pluto data set put out by New York City. And this is actually looking at every single tax lot in the city and has information about what's built there. So when you download this data, you'll see it's a pretty substantial data set, obviously being every single building in the 5 boroughs. And we'll be sort of looking at a few strategies of dealing with this large data set. So what I ended up, and I actually posted, did everyone see the video that I posted going through BigViz? Was that clear? I just put it in the meetup info, and it sort of goes through just a few samples of how to work with BigViz. So BigViz basically, it's sort of actually written by Hadley Wickham, and it's kind of a proof of concept of his to use what's called the RCPP package, and that leverages the speed of a lower level language, C++ in this case, to really sort of do big data operations. So in the video, I went through sort of how how you kind of deal with a large data set in this way. So really what BigViz is about condensing and binning. So you're looking, and I won't go too much in depth into that during this meetup. So check out the video for when I do sort of go into that script. But it's basically sort of strategies of binning data. When you are looking at large data sets, like with the Fortune 100 companies, we were able to sort of have every point show it as a scatter plot and still kind of see something meaningful. But when you do have truly large data sets, that quickly becomes unwieldy. So BigViz is sort of a way of working with that, and it has some built-in plotting functions that let you that let you sort of create plots out of those binned data structures. Has anyone not seen that yet, the video? Or if you have, does anyone have any questions about? The link is. I'll have to just get into Blackboard for a second here, but the link should be in Meetup info. So here, I just posted it. Or I'm sorry, I think I put it in, I didn't put it here, but I put it in one of the announcements. So I'll actually put it in the Meetup info just so that it's there, but it was basically in this week 3 announcement here. Cool. So so check out that video if you haven't taken if you haven't checked that out yet. Has everyone at least tried to install BigViz? There is you do have to install it from GitHub. It's not you have to sort of use DevTools to do that. And I saw a few people having issues in the discussion board. Cool. So I see a lot of people had that installed. So feel free to use the discussion board if you do have any issues with getting that installed. And if all else fails, email me and we could sort of work through that. But the discussion boards have a lot of good, sort of you're able to see what other people have done in trying to install it. Perfect. Cool. So with that, we'll just dive into what we've been doing on the discussion board. So there has been a lot of interesting points in terms of, and actually, I'm sorry, I meant to go to one thing before I move on there. So yeah, this data set, it's the Pluto data set. We're looking at every single observation there. Does anyone have any other questions about the data set itself, and sort of what's being asked in terms of bringing it into a workable format in R? Is this in the Pluto data set? Okay.
In the Pluto data set.
Hello? Tala?
Yeah. Can you hear me?
I can hear you, yes.
Yeah, no, this is, I was just asking about the Pluto data set because I thought the homework was due a lot sooner than it was, but when I was calculating like the value per floor, there were a lot of there was a lot of high outliers. So I was just wondering if you want to filter. I mean, if you expected us to filter it or something like that.
I believe it shouldn't really. I'm trying to think of those particular outliers. I don't think, but I don't think so. I think you should be able to just manage
For number three.
for number 3. So are you saying individual? Oh, okay. So now, are you saying like some years are showing up as outliers?
No, like for example, when you do the assessed value per floor
Uh-huh.
for each of the building properties by year, you're getting some really high. You get a range, obviously. So that's what I'm
Okay. Let me. I'll actually have to take. I'm not remembering off the top of my head what I did. I think I. There might have been some. I think there might have been something happening with the with sort of shorter buildings and kind of buildings of like one story, like mostly single family homes that might have been screwing things up. But I'll put an announcement if you need to do something there. But because especially for question 3, since it's aggregated by years, unless I say otherwise, unless I post an announcement saying otherwise, you should be fine with just using the data as is. Like I think, yeah. So I mentioned like look at buildings built since 1850 because you get some weird outliers there, and then you're sort of expected to have outliers in terms of tall buildings. Um, you have a lot of sort of walk ups, different types of buildings, and then you sort of have a smaller number of skyscrapers. So you're expected to have some odd distributions there. So I think you should be fine just with the yearly aggregates for number 3. But I just want to check on my notes to make sure I'm not wrong on that.
Sure, thanks.
Mm-hmm. Cool. Any other questions on the assignment here? Cool. And one other thing I wanted to move into in terms of looking at larger data sets is, and this is actually a package for Python. So we haven't gotten into Python yet, but and when we do get into Python, I'm not going to focus too much on this particular library. But since since this module we're talking about large data sets, I thought it was worth going through what other options there are out there. And one of the more recent additions is from Bokeh, and this is Datashader. And Datashader is pretty much centered around different pitfalls that occur when you are dealing with large data sets, and it basically kind of creates ways of dealing with that. So here and you can sort of check out a lot of these examples in the example notebooks that they provide. But you have things like overplotting. So here you can see when you have 2 scatter plots, depending on which is on top, you get a completely different picture. And then it sort of shows ways that you could deal with that. So, a lot of times you're dealing with binning where you could, sort of get past problems like this. But in this case, if you just simply change the opacity, that's another way of avoiding a difference between, in this case, C and D, having blue or having red on top. And this kind of goes through a lot of cases where these kinds of things can help. So if you guys are good with Python, I would recommend checking this out. But this is sort of, Python, this is Bouquet's take on dealing with the problem of large data sets. And they have some pretty cool examples. Like they have in using the New York City taxi data, you're able to get like a large number of points pretty clearly shown. And in general, sort of characterizing this with other methods, BigViz is more geared towards binning the data, whereas what this is actually doing is sort of having strategies of actually mapping out all of these points. So in this case, this is similar to what I mentioned before about how you could just simply view a scatter plot and view everything, but with a larger data set, you could run into issues. This kind of automatically deals with that. So I'll post this link in the chat, and you guys could kind of check that out if you're more into Python. So with that, I'll just move into a few sort of the what we were talking about on the discussion boards, and trying to sort of pick up those conversations and talk a bit more about what people were noticing about these data viz concepts. So starting out with ChartJunk, I mentioned a few sort of posts here. I mentioned a few people who posted them. So does anyone want to pick up what they mentioned in the discussion board? So perhaps Sharon and Judd, if one of you, like, we could sort of look at either side of how ChartJunk distorts visualization. Sharon, I saw you unmuted yourself. Your microphone might not be working. Well, and Tala, I saw you unmuted yourself also. Did you want to touch on this?
Yeah, I can definitely speak to some of the comments I made.
Mm-hmm.
There were two comments basically that I guess now that we have sort of, it's, in the olden days you had to sort of take pen and paper or print a lot of the graphics, but now you can obviously make them through computer graphics, etc. So it's a lot easier to create ChartJunk. And then the other thing was, it's more, sometimes it depends on who your audience is, right? Sometimes we had some of those charts that were a lot more, that would probably be a lot more memorable than other one, without the ChartJunk, for example.
Mm-hmm. Yeah, and that was an interesting, like, sort of getting on, what Sharon and Judd were, and yeah, sorry, Sharon, your microphone wasn't working, so we could try that again next meetup. But there was some interesting discussion about whether or not ChartJunk actually does, sort of decrease the understanding of a visualization, or does it make it more memorable? And one sort of point that I thought was compelling was, if you are like, part of me was thinking, if it is adding to the understanding of it, then there's something technically, like, there's data mapped to that. It's so if you take it away, you're taking away actual something that's meaningful in the graph. But perhaps something like ChartJunk could be seen as a sort of an extra dimension. So sort of what I sort of looked at here was you could almost think of it as like an emotional dimension where you're looking, and in the discussion boards I was for some reason I kept on thinking of like the stock market like a roller coaster, something like that. That's and kind of looking at it bluntly, you could definitely classify that as chart junk and saying just have a spark line and show what's happening. But it definitely in that way it does kind of add to just almost the feeling of what's going on. So in that case, definitely like it could be seen as an emotional dimension. So there were a lot of interesting points points there. That's sort of one avenue that I could see chart junk sort of adding to a visualization. And then I believe I mentioned this in week 1 when we were talking about the data to ink ratio. But the really when we are looking at things like this, we do also have to remember that the point of a visualization is to get its point across, to be and it's not not just to be art, not just to be memorable. So while kind of like there is a balance, which a lot of people touched on, but that's just something to keep in mind, that memorability isn't really what we should be focusing on. Anyone else have any comments on chart junk before we move on to small multiples? All right. So so I actually found a lot of interesting things in the discussion on small multiples. One particular interesting example I found was Raphael's, and really what I found compelling about this example, so I have that over here, is how it's a kind of more traditional look at small multiples. This is pretty standard, what you would get in on paper. So the interactivity isn't adding anything to it on the surface, but what you are able to really get is a nice look at comparison. So they synced up, so 538 synced up the tooltips to really show the comparison among the different presidents at a point in time. And so in this way, this is a very sort of key example of how when you do have interactivity, you're able to add to these more classical visualization concepts. So that was a really cool example there. And Raphael, you on the call? Don't think he's on. Cool. So and then the second point, this is kind of touched on by a lot of people, and so I kind of summarized it here. But this is just looking at whether or not more interactive environments lead to replacements for small multiples. So the 3 sort of key examples here, we had animation, drop downs, and 3D, and sort of looking at what sort of how those may serve as replacements. So does anyone want to comment on one of those? Cool. So so yeah, basically what this looks at is it's just looking at like like small multiples. They're usually spread out in this way if you're just dealing with a static image, because that's the only option you really have to show sort of these sorts of comparisons. A lot of times used for comparison. And Tufte, when he's going through small multiples, he'll also talk about how it could be used to show motion, show change. And you could kind of have an idea of which which one of these kind of what other ways of looking at these comparisons could work. So for something like this, where we're looking at precedents, we're looking at kind of a direct categorical comparison. Which one of these do you think would sort of work best to kind of replace small multiples? So if we were looking at this, and instead of having traditional small multiples, we wanted something else. Which of those do you think is the best way to show something like this? Feel free to type it in if you don't want to use the microphone. So yeah, anyone? So basically, the the point that I was just trying to make is, when you are looking at different kinds of comparisons, they might be better served by different replacements. So for a straight categorical comparison, you could easily use something like a drop-down, where you want someone to be able to pick different exactly, yeah. And Alex just typed drop down, so it's could let you look at examples next to each other, or it could just simply allow you to pick which one you're looking at. So you can imagine kind of the simplest way of looking at something like this would be you have a single line graph, and like a single panel, and you choose who you're comparing Trump to. So you're able to kind of make your choice like that. Whereas if you're doing comparisons over time, and a few people posted them, but I didn't end up bringing them into the PowerPoint here. But a few other people sort of looked at comparisons over time, and for something like that, one of the sort of best replacements is an animation, and a few people posted examples of what that looks like. So that's something that wouldn't really make sense when looking at a categorical comparison like this, but it does make sense if you're looking at changes over time. You're looking at different years, and you want to sort of see how that change is occurring. So that's just sort of one thing I thought was interesting in terms of different replacements. So that's pretty much it I had for this meetup. Does anyone have any other questions about upcoming homeworks or anything else about the class? All right. So yes, Walt, I do still need to update the syllabus. So let me actually do that. I'll do that later today. And in terms of the project is, I'll post more information about this. I believe I don't have the link itself, or I do. Yeah, I have that. Yeah, I didn't make these visible yet, so I'll sort of talk about a bit about that. In I believe 4 or 5 weeks, I'll have to check the exact date. Your proposal will be due, and the project is meant to be more of a pretty free form. So you're able to pick your own data set and pick an interesting way of visualizing that. Right now we're looking at sort of more, we're sort of just starting with the fundamentals. And things will make more sense once we get into module 3, which is which gets into Shiny, and that's sort of overviewing more, interactive visualizations, and really that's going to sort of be the most comparable to what your final project would look like. So for the final project, you could sort of use a framework like Shiny, or using, we'll be getting into D3 and JavaScript. So hopefully some people choose to sort of just to use that, but it's basically meant to be pretty free form. And for the next lecture, I'll make sure to post a bit more. I'll post a bit more, and we'll sort of go more in depth for the final project. Any other questions? All right. Thanks a lot, everyone, and good night.